Example 13. A horizontal force of 1 Newton is required to move a metal plate of area 10 raised to minus 2 meter square with a velocity of 2 into 10 raised to minus 2 meter per second. When it rests on a layer of oil 1.5 into 10 raised to minus 3 meter thick, find the coefficient of viscosity of oil. So let's understand the given problem using the following diagram. In the given diagram, we observe an oil drop on which a metal plate is placed. If we apply a force of 1 Newton horizontally in this way, this metal plate will gain the velocity dv, and its value is given here, 2 into 10 raised to minus 2 meter per second. The area of this metal plate is 10 raised to minus 2 meter square. Now we have to find the coefficient of viscosity. As we know, the coefficient of viscosity of a fluid is a measure of resistance to flow of the fluid. Here, initially, the fluid is having a velocity v because of its internal molecular motion. But when the metal plate is being experienced by the force, it will gain velocity dv, and that velocity, because of this contact, being transferred to this oil drop. And now this oil drop will also starts moving with velocity v plus dv. As we know, this oil drop is made up of n number of layers. Just now I said that the velocity of entire oil drop is v plus dv, but in figure 2 it is observed that the velocity of uppermost layer, that is layer 5, is only having that velocity which is v plus dv, but the velocity of layer 4, 3, 2 and 1 is getting decreased by an amount of dv. So what is the meaning of these velocities corresponds to this different layer, and here is the concept called viscous drag force comes into the picture. We will discuss that concept in detail in the next slide. So in the figure 2, we observe that the entire oil drop is represented in the form of layers. For simplicity, we take 5 layers, but actually there are n number of layers. Interestingly, each layer having a thickness dx that we have to consider initially. Now the layer 5 is in contact with this metal plate, and the metal plate is experiencing the force of 1 Newton. Because of that, it will gain velocity dv, and initially each layer has velocity small v, but because of the contact with this metal plate, the layer 5 will gain velocity dv from the metal plate, and the final velocity of layer 5 is v plus dv. Now layer 4 is having only v velocity. Now how does this come? So for that, let's look at this table. In this table, we observe that layer 4 has final velocity v. It has a thickness dx just like thickness for layer 5. Now we will understand the meaning of this v plus dv, v and v minus dv concept. So final velocity of layer 5 is v plus dv, in which the small v is the velocity due to random motion of molecules in layer 5. This is the initial velocity before the metal plate being in contact with the layer 5. So initially each layer has velocity small v, which is the velocity due to random motion of molecules in layer 5, and dv is the amount of velocity gained by layer 5 from metal plate due to the motion of metal plate, as this metal plate is being experienced by 1 Newton of horizontal force, so that the final velocity of layer 5 is v plus dv. Same way, the final velocity of layer 4 is v only. Initially, the velocity of layer 4 is v plus dv, in which the small v is the velocity due to random motion of molecules in layer 4, and this dv is due to the motion of metal plate. Now this minus dv is the velocity due to the viscous force provided by layer 5. As we know, the viscous force is the force between two layers which are in contact, and here the layer 5 and layer 4 are the two layers which are in contact, in which layer 5 will provide a viscous force in order to oppose the motion of layer 4. So this negative sign is an indication of decrease in the velocity of layer 4 by an amount of dV due to the existence of viscous force between these two layers, that is layer 5 and layer 4. The same way we can find the velocity of layer 3, and that is given here, which is V minus dV. So let's find that velocity here, that layer 3 has a final velocity V minus dV, that is because of V plus dV, which is the initial velocity, in which this V is due to the random motion of molecules in layer 3. This dV is due to the motion of metal plate. Now this minus dV is due to the viscous force provided by layer 4, and this minus dV is due to the viscous force provided by layer 5. So in this way we will find the velocity of each layer, and it is observed that each layer has a distinct velocity, and if we go down towards the bottom, the velocity of corresponding layers is getting decreased by an amount of dV. This is what the conclusion from the given discussion. Now let's discuss about the distance from bottom. Let us consider here that layer 4 is at a distance of x from the bottom, so that layer 5 is above the layer 4 and the thickness of each layer is dx, and hence the distance of layer 5 from the bottom is x plus dx. So we write here x plus dx as a distance from bottom. Layer 4 we already consider it is at a distance of x from the bottom. As layer 3 is below the layer 4, and hence we have to subtract thickness dx from this x distance, and hence the layer 3 has distance from the bottom is x minus dx. Let's have a look on some important definition which helps us to solve the given problem. Viscosity. It is the property of fluid due to which a relative motion between the different layers of a fluid experiences a dragging force. So in our problem, that the layer 5 and layer 4, these are the two layers which are in contact, will experiences a dragging force, and this force is called viscous drag. As the viscous drag force is directed opposite to the direction of velocity of fluid layers. So in figure 2, this layer 4 is actually want to move in the right side, but because of the viscous drag force, its velocity is getting decreased, and that can be indicated by this length of the arrow. As the velocity is a vector quantity, we can consider this length of the arrow as a magnitude, and we found that the magnitude of this velocity is decreased by an amount of dV. So for each layer, it is observed that the dV amount of velocity is getting reduced from the given velocity, and hence the length of this arrow is decreasing as we tend to move towards the bottom. So what is the result here? At the bottom, the velocity of layer is approximately 0. So this is one reason due to which a fish can swim easily at the bottom side of the water bodies. So in liquid, the viscous drag force is due to the short range molecule cohesive force, and in gases it is due to the collision between the fast moving molecules. The second definition is velocity gradient. The rate of change of velocity dV with distance dx measured from stationary layer is called velocity gradient, and its ratio dV by dx is representation of velocity gradient. So these two definitions we are going to use while calculating the coefficient of viscosity of oil. So what is given in our problem, that the force on the metal plate, which is 1 Newton, surface area of plate is 10 raised to minus 2 meter square, the velocity of plate after experiencing the force, that is dV, is 2 into 10 raised to minus 2 meter per second. The thickness of layer of oil is, this is a single layer we are taking here, the thickness of layer of oil, which is 1.5 into 10 raised to minus 3 meter, and now we are going to find the coefficient of viscosity of oil represented by the symbol called eta. So we have eta is equal to force upon area into velocity gradient, that is dV by dx. So we'll substitute these values, that force is in 1 Newton, so entire things are in SI units, so no need to have a conversion. So 1 Newton upon 10 raised to minus 2 meter square into 2 into 10 raised to minus 2, that is dV, and 1.5 into 10 raised to minus 3 is the thickness, which is equal to 1 upon 4 by 3 into 10 raised to minus 1. So finally eta is equal to, this 3 goes up, so 3 by 4 into, and this 10 raised to power minus 1 is goes up with positive sign, so 10 raised to plus 1. So 3 by 4 is 0.75 into 10, that is 7.5, and the unit of eta, that is the coefficient of viscosity of oil, is Newton second per meter square. How does this come is given here, that eta is in Newton upon meter square into meter bar second upon meter, and this meter get cancelled. So finally Newton upon meter square per second, and the second goes up and we left with Newton second per meter square. So unit of eta, that is the coefficient of viscosity of oil, is Newton second per meter square. And hence the final answer is the coefficient of viscosity of oil is 7.5 Newton second per meter square. Thank you.